Hello, and welcome to this description of how to use Beauplan's maps to estimate population density of 17th century Ukraine. This presentation starts with an overview of our project, followed by a description of the sources of raw data used for this project. The heat map application used here to generate a population density heat map is then described, and the resulting estimate of population density of 17th century Ukraine is provided. We conclude by touching on some limitations of our approach. Starting with a brief overview, a choropleth map is a form of thematic map used to portray the structural characteristics of a particular geographical attribute distribution not apparent in data presented in tabular form. A choropleth map prepared by segmenting a region into a regular grid with each grid section shaded in an intuitive manner can be termed a heat map. We have created a Microsoft Excel VBA application that converts information contained in a worksheet of features portrayed on maps into a heat map, and then converts the heat map into a KML format file suitable for display using mapping systems such as Google Earth. The purpose of the project described here is to apply the heat map app to Beauplan's maps to estimate 17th century population density in the region covered by his maps. More specifically, the goal is to calculate the population density of each grid on a map of a region of interest, here 17th century central Ukraine. We will be using Beauplan's maps of Ukraine to create our heat maps. In 1630, Beauplan traveled to the Polish-Lithuanian Commonwealth to begin a 17-year military career in the Crown Army. His account of this period was published in 1660. In addition to providing a coherent tableau of 17th century Ukrainian landscapes, people, flora, and climate, Beauplan's works provides a major cartographic description of this region. Here is one such Beauplan map. Zooming in on the map, we see the type and level of detail provided by these maps. The symbol key from another such map shows the kinds of features that are represented on Beauplan's maps. Okay, but how exactly do we use these maps to provide the raw data needed to produce a population density heat map? To answer this question, we need to very briefly review our Beauplan's Ukraine Harvard Dataverse repository available here, and in particular, the Beauplan's Places in Ukraine section of the repository. Within Beauplan's Places in Ukraine, we find the gazetteer of Beauplan's Ukraine, which contains entries for over 3,000 habitations, rivers, river crossings, river rapids, islands, forests, mountains, and valleys shown on Beauplan's maps. You can access the gazetteer at this link. See the link in this video description for a tutorial on how to use the gazetteer of Beauplan's Ukraine. The gazetteer is provided in several versions, but our heat map app uses the CSV format file. Here is a section of the gazetteer that illustrates the raw data used for our population estimates. Note in particular the class and subclass attributes, the value of which is derived from Beauplan's maps, and specifically the habitation subclass value. We have identified 11 types of habitation features shown on Beauplan's maps, with one example being Christian villages. Now let's see how we use this information to create a population density heat map using our heat map GIS app. We won't go into detail on how to use this app, but there is a tutorial linked in the description of this video that provides instructions on how to use the app. Note also that you can download the app from the link shown here. For the heat map application, the various habitation types found in the maps being studied are entered by the user, and the user assigns a habitation weight in the range of 1 to 5 for each habitation type. Here, these weights represent relative population levels. So here we are saying that a Christian urban center has 5 times as many people as a Christian village. The result is that urban centers have 5 times more influence on the heat map than do villages. Note that these weights are arbitrary and are totally up to the user. So here this village has a population weight of 1 and the fortress has a weight of 5. To calculate the population density of a particular grid, we need to take into account the population weights of all of the habitations in the vicinity of the grid. Here is the equation that the Heat Map GIS app uses to calculate population density of a grid. As we just mentioned, the grid population density depends on the weights of all habitations, with habitations closer to the center of the grid having more influence than habitations far away. But before proceeding, we need to examine what effect grid range has on the calculation. How this works is that a large value of grid range means a greater influence of distant habitations. So large grid range values tend to smooth out a heat map at the expense of detail, as we will show shortly. As mentioned, the Heat Map GIS app produces KML format files that can be displayed in apps such as Google Earth. Here we see the population density grids turned on. And here is a zoomed in view with the features layer turned on, revealing the individual habitations used to calculate the population density of the map grids. Note that habitation icon color depends on habitation weight, as does icon size. So a village gets a small blue icon and a fortress gets a large red icon. To see the effect of changing grid side length and grid range, here is a heat map with 5 kilometer grids and a grid range of 2 kilometers. And here we use a grid size of 5 kilometers and a grid range of 5 kilometers. As you can see, a larger grid range tends to smooth things out, but at the expense of detail. That's all well and good, but let's move on to some results. Examining the highest population density region of our heat map, as expected, we see the strong influence of major rivers on population density. Zooming in on the region of highest population density, we see the fortress of Halich at the center of the region. What we also see is a high density of fortresses in that region, as well as a high density of villages, which accounts for the high population density in this region, which is reflected in this Beauplan map of the region. Zooming in on a relatively high density region, we once again see a high density of fortifications, cities, and villages. Checking out one more relatively high density area, we once again see the reason behind the high population density estimate. Here, we have used our heat map app in a slightly different way. Looking at only fortifications gives us an idea of the most highly defended regions of 17th century central Ukraine. Changing the heat map parameters reveals a highly defended area in the east of this region. Zooming in on this region, an associated Beauplan map shows a number of fortifications in this highly defended region. Zooming back out of our fortification heat map, we see what appear to be two fortification gaps. Zooming in on the gap centered on Tomaspol, we see a corridor between the rivers running right along the Czarny Szlak. To learn more about the Czarny Szlak route and other travel routes shown on Beauplan's maps, see our Pontic Paths presentation linked in the description below. Here is the poorly defended region as shown on this Beauplan map. What is particularly interesting is to see how this gap aligns with the course of the Savran and Kodama rivers, which were at the heart of the 1542 border dispute between Poland-Lithuania and the Ottoman Empire. See the link below for a description of this dispute. In conclusion, we should note some important limitations of the heat maps produced here. First, the heat maps utilize only the places that cartographers put on the maps used. Second, we rely on the cartographer's assessment of habitation subclass. And when using multiple maps as we have done here, different maps may have different symbols for the same place. As noted, population weights are arbitrary, but can be altered as evidence dictates. Finally, the weights rely on the analyst's interpretation of map symbols. For example, this is definitely a fortress, and this is definitely a stockade, but is this a fortress or a fort? The redeeming factor is that we did use over 2,500 habitation features to create the heat maps shown here, so interpretation of individual habitations may have little impact on resulting heat maps. Thanks for watching this description of how to use Beauplan's maps to estimate population density of 17th century Ukraine. We hope you found this material useful to you, and don't forget to see the links below for related videos.